Hello everyone. Thank you for joining in to learn about AWS Lambda function. So in this tutorial, we'll be covering what is a Lambda function, how does a Lambda function work, and what are the core features of a Lambda function and the use cases of a Lambda. Right, let's dive into it. What is a Lambda function? So it is a compute service, which is also a serverless service that is offered by AWS. And the best part of the Lambda function is that you just have to worry about writing the code or the script rather than worrying about setting up the environment, or I would rather say setting up the servers and managing the servers. So it gives us the ability to focus mainly on the business logic rather than the hassle about creating the servers. Also, these Lambda functions will save your cost. Let's say there is a use case where you might not get requests all the time. So instead of setting up a service like using EC2 instance, you can rather use a Lambda function to do the job, so that you'll be only paying for the amount of time that the server or that the Lambda function is getting executed. And by serverless, what do I mean? So although you may not be setting up the servers, but internally behind this in the backend service, the AWS service, it creates a server and then it scales as per your computation needs and as per the configuration changes that you have made. Let's say your execution needed higher and higher computation. It scales up to that level instead of you doing it manually if a EC2 instance or similar service has been set up. Right. This is the basic workflow of a Lambda function. So it's a simple process. All you need to do is create a Lambda function using any of the mechanism, probably by CLI or SDK or even from the console, and then write your script, run the function. That's all you need to do. And your task is executed. Right. So these are the core features that I have laid down in order to better understand what a Lambda function is and what are the different things that you would need to know as a prerequisite before actually using the Lambda function. Let's go through each of them. The first one in the list is timeout. What does this timeout mean? So it's the amount of duration within which your Lambda function is supposed to get executed. Let's say your task actually takes 10 seconds of time, but the default timeout set for the Lambda function when created is 3 seconds. So, and your task needs additional 7 seconds of time. And what happens is ideally, after 3 seconds, the Lambda environment gets terminated, irrespective of whether the execution is finished or not. So, and the maximum amount of time that you can configure against this timeout is 15 minutes, which is equivalent to 900 seconds. So one must be very mindful about using the Lambda function when your execution needs to be, let's say, if your computation or the execution time needs more than 15 seconds, then it is highly not recommended to use Lambda as a service in your architecture. The next one is memory. Memory is the computation that the CPU computation that your task would require. Let's say you're trying to process an image or you're trying to run a basic script. So both these things would require different amount of memories. So based on your requirement, the memory needs to be configured. And the default amount of memory that gets configured is 128 megabytes. And the maximum that you can go is up to 10 GB, which is equivalent to 10,240 megabytes. And runtime configuration. What is runtime configuration? So like I said, although the Lambda function may be a serverless service, but it does require an environment in which your code will get executed. So that's where the runtime configuration comes in. And then this Lambda function supports various runtime environments. As you can see on the screen, it supports Python of various versions, Java of various versions, Node.js, .NET, and many other runtime environments. And in general, whenever these runtime configurations are configured, by default, the configuration will have the default packages which are present in those specific programming languages environment. And if you require additional packages, you either have to specify it explicitly in a file, or you would rather have to uh, include those dependencies as a part of Lambda packaging deployment. And the next comes the layer. Layers are basically a feature or a service which gives you the ability to bundle all the dependencies that are required for your Lambda function in order to execute. So in general, what happens is whenever you trigger a Lambda function, every time the Lambda is triggered, it tries to create an environment within the server, and then it gets executed. And this environment that you will be associating as a part of Lambda deployment will be an overhead, and this will be associated with, let's say you have a use case where you need 10 Lambda functions, and all the Lambda functions require a similar runtime configuration. So instead of including these dependencies to each of the individual Lambda function, rather what you can do is you can simply create a Lambda function as a layer and then include all your dependencies, bundle it, and then use this layer against all the Lambda functions so that you can actually avoid creating this overhead with each of the Lambda function. Next comes the concurrency. So the best feature or the best part of the Lambda function is that you can execute these Lambda functions in an asynchronous way. As in, each of these Lambda functions can be executed concurrently in an isolated environment. Let's say there is a service which will trigger these Lambda functions multiple times. So each time this Lambda is triggered, it gets executed in an isolated concurrent environment, and then each of these concurrent Lambdas will be monitored. These logs are monitored separately. The quota limit that you have against this concurrency is 1,000 per account. And by default, what happens is, let's say you have a single Lambda function and the concurrency is not explicitly set, but it scales up to 1,000 per account. And let's say you have 10 Lambda functions, and then the concurrency is divided internally as the request comes in. Cold start. So whenever a Lambda function is invoked, it takes some time to set up the environment, the runtime environment, which is needed for that particular function to finish its execution. So this might sometimes take very milliseconds of time, and sometimes depending upon the dependencies that you have, it may even go up to few seconds of delay. And this may cause a problem for few scenarios, may not be a problem in the scenarios where the Lambda is being used as an right. So this time is called as cold start, and this may not be the case. This may not be as impactful for few scenarios, but it may have some impact in few scenarios where you would like your request to be handled right away. So in such cases, there's a feature called provisioned concurrency, wherein you can specify a few set of Lambdas or a certain number of Lambdas to be in a you can reserve those many number of Lambda functions. And when this is configured, let's say you configure 10 as the provision concurrency, So the 10 Lambda functions will be in a warmed up state by setting up your runtime environment, and they'll be ready to handle your request right after they come in. So this configuration needs to be done mindfully. And the reason why I say is that you may, in general, if the provision concurrency is not set up, you'll be paying only for the duration of time that your request is being executed. But in case of provision concurrency, you will be paying an additional overhead amount for reserving your Lambda and the duration of your reservation. Integrations. So like I said, AWS Lambda is a core service of AWS serverless services, and this service actually provides integrations with almost most of the AWS services that require or that may need AWS Lambda as an integration. So as you see on the screen, it provides integration with S3, IoT Core, queue services, notification service, streaming services, Kinesis, Event Bridge, and many other services as well. And let us see a few use cases. File processing. Let us consider you have a use case where a user will be uploading an object, and then you would like to process that object before actually making changes to the database. So instead of having this as a service or running it on an EC2 instance, rather you can have it as a Lambda function, the script to process or the script to make the modifications of the uploaded file. What you can simply do is you can have a trigger whenever an object is uploaded to an S3 bucket, it triggers a Lambda function, and then the Lambda function actually processes that file, and then it makes the changes to the database. And it can also be used as a web application backend in collaboration with API gateway. So let's say you have a web application in which you are building REST APIs using API gateway. So every time a REST API is called, it triggers a Lambda function and the request will be handled. Or let's say there may be a few tasks which doesn't really require an EC2 instance to be set up, or such scenarios, you can also use this. Or let's say you have an IoT devices, you are having IoT devices, and then the IoT devices sends the payloads as an MQTT messages to the AWS, and then you can use this Lambda functions as a trigger whenever an MQTT message comes in. So you may process the MQTT message and then further do the required tasks. This can also be used in case of streaming applications. You can add this as a trigger to a Kinesis service, wherein after you get a set number of messages or the activities, and you can process those batches as using this Lambda function, and then update your databases or perform any other operations like that. So this way, Lambda has got many use cases, many advantages, and that's all for this video. In the next upcoming videos, we'll be discussing, or rather be coding the actual things. We'll be doing the hands-on of how and what the Lambda function is created, and we'll be covering different set of scenarios using which the Lambda can be utilized. That's all for the video. Thank you, guys.